Okay, so let's have a look at the Leaving Certificate Higher Level Maths Paper 1 for 2019, question 6. Now, in part A1, we're given this equation here, and we just have to work out what x is. Find the value of x where x is real, and we have to give our answer in the form a root 2, where a is some natural number. Okay, so let's have a look. We'll write it down first, and we'll work from there. X minus root 32 is equal to square root of 128 minus 5x. Now when they say here give your answer in the form a root 2, it should kind of give you a hint that possibly these two square roots here can be written in the form some natural number times root 2, and that is actually the case, but we'll have a look at that in a minute. Let's just start by bringing this minus 5x over to this side. So we'll add 5x to both sides, so 5x plus x will give us 6x, and let's leave this 128 on this side, and we'll add the root 32 to this side. Now if you take square root of 128, that's actually I mean, your calculator will do this for you, but if you take 128, you can see that that's just the same as twice 64. So square root, that will give us square root 2, square root 64. That will give us square root of 64 is 8, so we just get 8 root 2. But if you didn't do it this way, your calculator should do that for you anyway. So this here is just 8 root 2. Similarly here we've got a root 32, so you can see that root 32 is just going to be 2 times 16, which will give us square root 2 times square root 16. Square root 16 is 4, so we get 4 root 2. So this is just 4 times square root 2. So in other words, our 6x here is just 8 root 2 plus 4 root 2, which is 12 root 2. So that will give us our x here. Divide by 6, so that will give us 2 root 2. And that's it. We've given our answer in the form a root 2, where a is a natural number. Our natural number here is 2. That's it. Okay, so let's move on again. Now in this question we're told that a is the set, and we're given 4 very similar kinds of terms in the set. K is a natural number, and we've got to show that the mean of set A is equal to the median. So you've got to get the mean and the median of these 4 numbers here. Now if you look at 2 of these numbers, we have a 32 and a 128, same numbers we had in part 1, and we ended up with some natural number root 2, and I suspect that the other 2 were going to be something similar. So let's write down the 4 numbers. Now because we have to find a median here, I'm going to put them in order first. Now they're all the same with the exception of the coefficient of the x squared, so I can put them in order by just looking at those numbers. So the lowest one is going to be square root 32k squared. Next one is going to be the square root of 50k squared. The next one is going to be the square root of 98 k squared, and the last one then is going to be square root 128 k squared. Now we can rewrite these as, because the 32 is multiplied by the k squared, we can split them up. Square root 32 square root k squared. So really we've got here the square root of 32 times the square root of k squared. Well, the square root of k squared is just k. Here we've got the square root of 50 times the square root of k squared, so that's just going to be a k here again. Square root of 98 times k, and we have finally the square root of 128 times k. Now all of these can be written in the form some number times root 2. Now we did this one already. It was 4 root 2, so this here is just going to be 4 root 2 times k. 50 is actually 25 times 2, so in other words square root 50 is just 25 times 2. Square root 25 is 5, so we get 5 times root 2. So this is just going to be 5 times root 2 times k. 98 is 49 doubled, so 2 times 49, and the square root of 49 is 7, so here we're going to get 7 root 2 k. And 128 then we've done already, we found that was 8 root 2. 8 root 2, 8 root 2 k. So now I'm going to find the mean and the median, so it should be a lot easier to do that. So let's do the mean and the median. So let's do the mean first. So the mean here is what we get when we add all these up and divide by 4. So we've got 4 root 2k, 5 root 2k, 7 root 2k, and 8 root 2k. So we just got to add these up. So 4 and 5, 9, and 7, 16, and 16, and 8 will give us 24. So really we've got 24 root 2k. We've got to divide that by 4. This is our mean. So 4 into 24 will give us 6 root 2k. So this is our mean here. So let's work out the median then. The median in this case is the middle number of these 4 numbers. So because it's an even number of numbers, there isn't a median that's one of the terms. We've got to pick the 2 middle numbers, add them, divide by 2. So we're going to take 5 root 2k plus 7 root 2k. We're going to add those two and divide by 2. You don't even need to do this. You can see there's going to be the middle number between 5 and 7, which is 6 root 2k, but let's do this anyway. 5 root 2k plus 7 root 2k is 12 root 2k. I'm going to divide that by 2, and 2 into 12 will give us 6 root 2k. So what were we actually asked here? We were given this set A, these 4 numbers, where k is a natural number. We have to show that the mean of set A is equal to the median of set A. Well, we've worked out the mean as 6 root 2k, and the median is also 6 root 2k. So we can say, which implies the median of A is equal to the mean of A. And that's it really. Let's move on to the next one, part B. It's standard proof here. We've got to prove by contradiction that root 2 is not a rational number. So the way we're going to do this is we're going to use, well, they actually tell us here, we've got to use proof by contradiction here. So the way we do this is we have to prove that it's not a rational number, so therefore we assume that it is a rational number, and we come up with some kind of a contradiction at the end to show that that couldn't be the case. So first thing we're going to do here is assume square root of 2 is rational. It can be written in the form a over b, where a and b are integers, elements of z, and b is not equal to 0. So we are assuming that root 2 can be written as a fraction in the form a over b, where a and b are elements of z. Now we also have to assume that a also we put down here that a over b is written in its simplest form. In other words, the highest common factor of a and b is 1. So all fractions, all rational numbers can be written as fractions in its simplest form, where the highest common factor of a and b is going to be 1. If a and b have a higher common factor than 1, then they can be simplified. The fraction can be simplified down to a fraction where a and b, the highest common factor of a and b, will be 1. Okay, so let's start then. We've assumed that our root 2 is rational and that it can be written in the form a over b, where the highest common factor of a and b is 1. Okay, so we're going to say then that root 2 can be written as a over b. So that would just mean if we square both sides here, we get 2 is equal to a squared over b squared. That just means that 2 times b squared is equal to a squared. We just multiplied across here by b squared. Now, so b squared is an integer. B squared is an integer, which means that because a squared is equal to twice some integer, that means this 2 must divide into the a squared. If we divided both sides by 2 here, a squared will divide by 2 to give us some integer b squared. So that means a squared is divisible by 2, or a squared is even, if you like. Another way of writing that is 2 divides a squared. It's just another way of writing it. Okay, so if a squared is divisible by 2, that means that a is also divisible by 2. That's a separate kind of proof, but if a squared is divisible by 2, then a must be divisible by 2. So if a is divisible by 2, that means then that a is equal to 2 times some other integer, k we'll call it. So if a is divisible by 2, then we can multiply some integer, k we'll say, by 2 to give us a, where k is an integer. K is an integer. Okay, so what I'm going to do now is just substitute. If a is equal to 2k here, I'm just going to put this 2k back in here into this equation here. So I end up with 2b squared is equal to 2k all squared from this equation here. So we're just going to work on this now. So that would just mean that 2b squared is equal to 4k squared. So divide both sides by 2. That will give me b squared is equal to 4 divided by 2, which is 2k squared. So this means that b squared is equal to twice some integer. That means b is actually divisible by 2. If we divided both sides here by 2, b squared will divide by 2 to give me some integer k squared. So the way you would write that is as k squared is an integer, b squared is divisible by 2. And again, if or we can say here 2 divides b squared, if you like. If b squared is divisible by 2, that just means that b is divisible by 2. b is divisible by 2, or 2 divides b. Okay, so look what we've found here. We found that a is divisible by 2, and we found that b is divisible by 2. So if root 2 can be written in the form a over b, then a and b are both divisible by 2. But that can't be the case because the highest common factor of A and B is 1. Remember, A over B is written in its simplest form. A over B can be written in the simplest form where the highest common factor of A and B is 1. However, we've just proven here that A and B are in fact divisible by 2. So just to finish it off then, you would say something like, let's see, since A and B are divisible by 2, since A and B are divisible by 2, this contradicts the assumption that the highest common factor of A and B is 1. Therefore, square root 2 is, what way did they put it in the question? Irrational or not rational? Not rational, so we say. Square root of 2 is not a rational number. Okay, and that's it for this particular question.